We're going to come up with right away with our speaker of the day for the morning here, and that is Denis. Now, Denis, like I said, he's hailing from North Carolina, but a true Canadian had the opportunity to move down there and work with Belden, the flexibility of all of that stuff. He's an Belnerd ranchman, and as some of us are here, and he's going to be talking to us about the Open Compute project. I've known Denis for a few years, and I feel very fortunate. If there's any trouble I have inside a facility, I end up calling this guy, and I don't know how he does it. He walks in and he does some measurements, and he goes away and he comes back inside the data center floor on the white space, and he comes in and, Neil, I've got a solution. And and truly he does, and everything works out. So he's a great guy to have at your fingertips to call when you need some assistance. So Denis, I need some assistance up here. Can you come up here and begin your session? Thank you.
Sunil, thank you for having me. Okay, pleasure to be here today with you. What I want to make first of all, okay, I've been in the industry for about 26 years, 15 years with Nortel Telecom in Montreal, and for the last 12 years I've been living in the States, in North Carolina, and working for Belden, and doing a lot of projects both in the US and in Canada, so in the Toronto, Ottawa, Montreal regions. So I'm up here, you know, as many times as I can. You know, I always love coming back and seeing my friend here. What Neil wanted me to discuss today is specific to the Open Compute project. So I've been involved in Open Compute for about 5 years, and this started with relation with customers who were embarking in this Open Compute journey. So I want to share with you today a little bit of the Open Compute concept and where it's going, and why I think all of you should be a little bit, involved or question yourself if concept like the Open Compute concept apply to what you are doing, okay? So let me start with this here. Because I live in the US and I just got my US citizenship about 6 months ago, and my wife wanted to move back here, okay, right after that. So, kind of exciting to see that, you know, high-tech companies are backing up stuff that's very important. And talking of Open Compute, Apple, Google, Facebook, and Goldman Sachs are super active members of Open Compute. And these people are not wavering. They are not, being a good steward of our planet is important for all of them. And we see, this was a release yesterday from Apple, okay? Committing $1 billion in green grant to building, using renewable energy, and again, building energy efficiencies facilities. Huh? So not only because it looked good in press release, because it makes economical sense for people running really large, really big data centers. Okay. So agenda like Open Compute, what, when, why. I'm sure some of you have maybe been involved with Open Compute, maybe not, so I'll give you a bit of an update there. Momentum, so Open Compute concept, moving from what's defined as hyperscale data center to enterprise, to co-location, to other type of data centers. So these open concept being adopted in a much broader basis, okay? Open Compute project, so each of you can join Open Compute. It's free and you can contribute, so I want to share that with you. And then, you know, I've been involved with one project group that's called Open Rack, which the group is really looking into infrastructure and rack and power distribution in the data center. So I want to share this experience with you. And then what's next? What do I see as the next step in Open Compute, okay? So the Open Compute project was a startup of Facebook. So it was initiated by Facebook in 2011, okay? It was really, Facebook wanted to share their experience of their latest build, which was the Princeville data center in Oregon, okay? And about that, then discussing, how did they design a data center with a PUE around 1.07? I don't know if that's fully true, okay, where they measure it, but they claim, again, extremely efficient data centers, okay? And it's really about, like, maximizing operational efficiencies of large-scale data center, lowest possible cost of deploy and operation, okay? When you build these extremely large facilities, when you think of Google and Facebook and these type of companies, operational cost of data center is a big portion of their spending, okay? Purposely designed server, switch, storage, rack, and data centers. So designing with purpose. So let's remember that, okay? Then spurring rapid innovation, okay? Being able to, open participation, open contribution. So anyone with a good idea, anyone with something to bring can contribute to OCP. So no longer like proprietary solution, proprietary code where only the big guys can play. What about like smaller company with good idea and with talented people being able to come in and change course, change things, make leap improvement, contribute, okay? And it's funny, I was talking with a guy in Montreal 2 weeks ago from Dell, working on Bell's future networks, and he was explaining to me that he had this open platform, this open software, the open compute concept, where he could make a call 2 weeks ago, call a specialist in Paris who had a patch or a fix for his problem, and something that would have required months of work was solved in a couple days, again, because of open cooperation, because of people contributing openly to advancement of computing, okay? Open hardware, commodity hardware, white box, and disaggregation of the hardware. So that concept where I want my servers, I want my switches to be built in a way where it's extremely modular, where every component are fully disaggregated. So it's not a matter of having to wait for the complete, let's say I'm buying a new line of servers and a year in, a new chips comes out and this chip will do something very good for my organization. The concept of amortization and having to stick with what we have because of investment in these device. What if I could simply change component of these box, build around very established principle, and if there's an improvement we could make, I don't know, on more efficient server fans, we just swap fans out, put the new fan in. Same thing for the NIC card, the motherboard, all of the subcomponent of a switch or a server, okay? That's what open compute is about. So transitioning from proprietary solution to fully open gears, all right? That's where open compute is going, all right? So following a little bit on the model of open source software, like the Linux stuff, okay? Every year, normally it's in March, it's typically in San Jose, there's what's called the Open Compute Summit there. So about 5,000 to 6,000 engineers across the realm of the data center world show up there. And it's really about like open exchange. Neil was there with me this year, okay? It's really about open exchange. There's, on a regular basis, engineering workshops that are specific to the various projects in open compute. There's mailing list, and all these things are fully open. These are project and group where any of you could decide to become a participant. All right. So OCP started in 2005 and 11 when it was launched. There was 5 companies involved with open compute. Okay. As of today, there's over 220 of them. Okay. Among these companies, you've got company obviously Facebook, Microsoft. You've got Cisco just joined late in the game. Okay, Google. A lot of the telco companies start to be involved in open compute. Okay, so AT&T, you've got, you know, well, AT&T, Verizon, SK Telecom. I know some people from our big telco company are involved in open compute. So adoption, there are people very, very curious in the telco world. Ericsson up there, okay? And then you've got a lot of the financial companies are interested in the work being done in open compute. So Bank of America, Capital One, Fidelity Investment, Bloomberg is involved. So a lot of the financial companies are very intrigued with what's going on there. And then you have a bunch of the OEM, Microsoft, IBM, Intel, that are also very involved in OCP, okay? Open compute and open hardware, when you think of like some companies like Cisco's and the Juniper of the world, at start, many of these companies were looking at OCP, you know, from far away, hoping maybe that it was going to dissolve, okay, but it did not. OCP is getting a lot of momentum with more and more participation, okay. So now you've got, you know, on the left side there is, you know, announcement that Apple and Cisco have joined, you know, OCP. That was in 2015, okay. That was a pretty big deal, okay. And then that Google, late 2016, also joined Open Compute. So the notion of companies that are not enemies, but companies like Facebook and Google who are running their own data center in their own ways, to see them come together and be able to work on a common platform and dedicate, you know, engineering resources to advancement of open computing shows that I think the open compute was building a lot of momentum. The train was getting really big with a lot of large players in it. And at some point, companies that, you know, were a little bit reluctant, I think we're seeing this train leaving the train station and decided to jump in because I think the vision of opening up the hardware completely, it's not going to go away, okay? The notion of commoditization and the notion of you know, define around, you know, share specification of the hardware is a place where it's going, okay? So there's no stopping of that train, okay? In OCP, there are 9 working groups, all right? They're there. So a group is looking at compliance and interoperability, okay? It's clear that when you have like these open devices, you know, if I'm a bank or if I'm a large healthcare provider, it's clear that I want to make sure that these things have been tested together for making sure there's no issues in these working together. I'm thinking of server storage, I'm thinking of direct attached cable, networking cable, and all that good stuff is being tested. A group working on data center design, hardware management, high performance computing, networking. So this group specifically working on switch design and on agreeing on spec for the switches. Again, these are all working groups. Any of you can decide to participate in, okay? Working groups, you could decide to be on the mailing list when there's work and where there's development, when there's call and WebEx on, all right? The Rack and Power group, that's the one I've been sitting on for about 4 years, and I'm going to be talking in a little bit more detail about. A group working on servers, on storage. And the last one, I think, was created less than about 10 months ago. It's the Telco group. And this is where many of the large phone companies, but were phone companies that are much more now service provider company, okay, are part of. And these people are looking at, you know, how can open compute architecture be applied to large network. I'm thinking of AT&T and SK Telecom and Dutch Telecom and these type of companies, potentially Bell Canada and these type of companies. So then moving to fully open architecture, okay? The networking group have come up with standard design top of rack switch, core switches. These things right now are fully available for purchase, okay? So I can go on the Open Compute side, download the full recipe of how to build an Open Compute top of rack switch, an Open Compute core switch, okay? all built around defined building blocks. And these components, again, are fully available for purchase. So it's not like Open Compute is a wish. It's right now. It's if you go in any of the Facebook data center, you're going to see switch, top of rack switch, core switch, edge switch, designed around the Open Compute, and it's working. It's being applied as we speak. Okay, so and then again a complete line of servers. All right, I just picked this one because it was HP. So HP came up in 2015 with a line of servers built around Open Compute. Okay. So when you think about it, even like the key supplier, Dell, HP, are coming up with line of equipment that are designed to work into the Open Compute architecture. Right? So now I'm going to jump into the Open Rack. Okay, and I've been involved with Open Rack. I've not been involved with the networking. I'm not a switch expert. I'm not a server expert. I'm an infrastructure guy. Okay, so I build. I'm able to do whatever you need made of steel in terms of rack and containment. So let's think about like Open Rack. So this is the first meeting, and this was about like, it's a spec that's about 70 pages, and this is the first paragraph of the spec. And it starts with, adhering to the following, okay, open, fulfill, okay, goal of maximizing operational efficiency of large data center. The first one, installation and service operation are located in the cold aisle. Cold aisle, in the front of the rack, is my guess, huh? We agree? All right. The second one is, data cable are located on the front of the rack. So when I look at an Open Compute stack, no connection in the back, they're all in the front. All of them are in the front, okay? All right, so NIC card, output for my 40 gig on my servers, it's all in the front, okay? Component fault are identifiable from the front of the rack. Routine service procedure do not require a tool. Non-recyclable material. Design are vanity free. So no big plastic molding in the front, no big nice color. It's all pretty squarish, metallic type box. Okay? And then the last one, rack are integrated directly into the data center air containment solution. So the rack are part of the air containment. Rack are integral part of the management of the airflow, supply air, return air in the data center. Okay? So where are they going with this? They're going in a place where, they want, when I'm thinking of building the space, building the data center, building racks to hold my stack of machine, it's really about, for them, it was about making sure that the human factor, the human having to service machine, will at no point interfere with, how far we can push the notion of efficiency in the data center. So if my tech guy have to walk in the back and go in the hot aisle to work on the power distribution, the PDUs, or have to go in the back to connect networking cables, okay? I'm assuming that this person there might be exposed to very high temperature. So at some point, the human factor will become a limiting factor on how high can I push my supply air temperature to be. So what if Intel come up with this a chip in 5 years that will be running at 40 degrees C, and I would like to push the supply air temperature in values, upward of 30 C with exhaust air temperature of 45, 50 degrees C. Okay, so the notion of let's make sure that all service is done from the front. The back of the rack becomes a no man's land. It's designed for air circulation purpose to bring the hot air back, a defined path back to my crack unit. Okay. So that's pretty. That was a pretty strong, starting statement about where they're going and what they wanted to make sure would not become a limiting factor down the line. Okay. Another thing they did really quickly, okay, like the EIA standard, the 19-inch mount EIA standard, which no one really knows where it comes from, but it's been there forever, okay? So open compute, the people there started from a clean sheet, and they've looked at the EIA standard, and it was a question of why. Why is it 19-inch mount, and what's the purpose behind it, okay? And the notion of this standard being created in the 1910, 1920-ish, when people were working on electromechanical relay for railroad, and that's why a lot of people call them relay rack, okay? So one of the first thing, and it's kind of funny to think that even a brand new Nexus 7000 series switch chassis is 17.75 because it needs to fit in standard racks, okay? And this is, again, a standard that comes from way back then, where there's, again, from a technical standpoint, it's hard to justify. So in OCP, this is like a standard rack RU, rack unit. OCP, they went away from the rack unit, so they went to a wider frame. So the equipment is 21-inch wide. And what they define as one rack unit is one OU unit instead of a rack unit. And the reason they did that is they wanted to be able to fit 3/2-width motherboard width-wise on one chassis. You cannot do that with a standard 19-inch mount. The other thing they wanted to do is increase the RU size so we can go with server fans that are bigger, okay? So a 2RU server now have fans that are 80 millimeter in diameter versus 60 millimeter for a normal EIA standard rack. By doing that, you just reduce your server fan electrical consumption by about 20% because the bigger server fan move more air with less energy, okay? So very key reason why they went with that. Okay, so this is what an OCP server look like. So I've got my chassis. In this case, it's a design with 3 of the server. Okay, very similar to what you've seen on the HP on the other picture I've shown you there. Okay, but again, the notion here is built with purpose, built with vanity free, and all of these components can be swapped out of this server chassis and be replaced whenever your organization think it's the right time to change it, all right? So not having to wait for the complete box to be replaced and for major investment to be made, being able, again, to swap component, the notion of disaggregation, and be able to, again, implement innovation when it makes sense and not having to wait for nothing, all right? This is an open compute rack. Again, look-wise, it's absolutely vanity-free compared to some of the other rack out there, okay? Designed for service for everything in the front, okay? No connection, no networking connection in the back of the server, of the open compute rack. This rack is something like 23-inch wide for 21-inch mount, and it's something like right around 36-inch deep, okay, in the open compute Facebook version. And you have a small company called Google that came in about a year ago, and Google introduced a variation on this rack. So there's a variation that's about 30-inch deep that Google is using in their data center. So now in open compute, there's two equipment depth. Okay, so that's the post of the open compute rack. So in open compute, there's no longer like screws to mount your equipment. It's all slide in, so it's toolless mounting, all right? And the other big thing in open compute is the depth of the equipment is completely defined. So in open compute, when you open an open compute rack, or when you look in the back of an open compute rack, it's no longer a stack like this where my firewall, my top of rack switch, and then I have other devices, and it's all staggered like this. In open compute, it's a perfect straight line, okay? The reason for that is whoops. Neil, where are you? What did I do here? I touched something.
Oh, Denis, you're finger trigger happy, aren't you?
Gosh. I did something really bad. I'm also, oh yeah? I broke the machine.
Give me your remote for a second. Fancy button there.
What is that?
Buddy, this is the open compute mess.
Okay, we're back. We're back in business. Good.
There you go.
All right.
There's too many buttons on that.
Yeah, too many buttons. Okay. Okay, but Neil, it's not working anymore.
Oh, come on.
Okay.
These fancy remotes.
Or I can swap. I'm going to swap it right
over here and
Yep.
continue on, and I'll set you up for shortly. You got some fancy animation. See again?
Okay, good. Which one? I'm just clicking there.
Just click there. You can advance with this arrows too.
Okay. All right. The other big thing with Open Compute, okay, there's no longer like standard PDU in the back of the rack. So you've got like power bus bar, vertical power bus bar, copper bus bar that are located in the back of the rack. Oops, it's working again. Super, okay. So copper bus bar, so you've got like a meeting clip on the switch and on the server that mates with a DC power bus bar that are located in the back of the rack. So you need to imagine that the distance, the depth of the equipment, the way the rack is built, so when you push your equipment in, when you slide your equipment in, it latch in a place where the server clip is mating in the proper way with the bus bar. Okay, there's two bus systems. One is a 12 volt. This is the one used by Facebook. This is the one that was initially pushed in OCP. And now there's a new one, a 48 volt DC power bus system. And this one was brought in by Google again. So Google, in their data center, uses 48 volt DC at the rack level. So imagine like I have my stack of gears, I've got this bus bar in the back of the rack. It's the notion of I do not want to limit efficiency by having tech guy or girl go in the back of the rack and having to physically connect cord to a PDU. So everything is done from the front, including power connection, because the clip are going to mate in the back. So a completely new concept. So this is, I'm not going to go into detail of the power distribution, but yeah, what comes to there's a power shelf. It's a rectifier, an NEC to DC rectifier. So in most of the Open Compute data center, there's a standard plug. In this case, I'm showing here an L2130P, so that would be a 208 30 amp Y. So I'm going to connect my power shelf to let's say a bus way above. And what's going to come out at the rack level are this either 12 volt DC or 48 volt DC.
Is Google building those specialized components themselves, or are they getting another manufacturer?
You know what, huh? They're subbing out these components, same thing with Facebook. And everything I'm showing there can be purchased tomorrow from standard supplier. In this case, the company is called Delta. Okay, so these components are actually available out there on the market. All right. Okay, so new ways, and again, this is one of the Facebook. This is the one in Prineville, Oregon. Okay, and it's really all of this is around efficiencies. Okay, so computing efficiencies and operational efficiencies. And in a data center like this one, I can push my supplier temperature to values that are kind of a little bit crazy. I know Facebook have one in Forest Hill, North Carolina. Their normal supplier temperature is 81 degrees Fahrenheit there. I'm thinking in Fahrenheit, okay. All right. They let the supplier go all the way up to 85 degrees sometimes. And their goal there is to be able to use airside economizer in North Carolina, okay, around 250 days of the week. all right? So their concept of like they're pushing their machine to extreme limit and they're demanding from their supplier to guarantee, you know, availability and uptime at this type of supplier temperature, okay? I'm almost done. Open Bridge Rack. I was directly involved there. A lot of the companies said, oh, you know what, open compute, it's all really nice, but I'm a big financial organization. We're interested in open compute, so we're planning phases of adoption of open compute. We're buying racks and enclosure for our data center right now. So we work with Fidelity Investment to create or to bring to OCP a contribution that's called the Open Bridge Rack. And this is really a rack that can be converted in the field when needed from standard EIA to OCP format. So a rack where you can flip rails inside. Okay, flip them, it looks like that. It looks like a standard enclosure. It's about 28-inch wide. And this rack can be, again, day one can be shipped in the EIA format. And whenever Fidelity or Bloomberg or these type of company are ready to phase out to OCP, they're going to be able to modify the rack there in the field to make this rack fully compatible with the DC bus bar in the back. So you've got like panels that allow these bars to be attached where the distance between front and rear are super defined, okay, and come up with a rack that's compatible to both EIA. Obviously, it's the full rack. You cannot have a portion of the rack in EIA's format and the other portion of the rack in OCP. It's either an OCP or an EIA rack, okay? The last thing I want to pitch to you here, okay, and I know it's small and there's a lot of discussion there, but the next step, what's the next logical or what's going on right now, and I've met with people who are working on this as we speak, okay? So you're thinking of open hardware, okay, the next step or the step that's being worked on by other people and including a lot of the members of Open Compute is really open source networking, so software-defined network. So what about the stack of, you know, a computing stack of standard white box made of standardly designed servers and switches? What about like layer 1, 2, and 3 code that is fully open? Okay, I'm thinking of the Linux Foundation here, and you've got AT&T right now working on something called eComp. And if you're code people, you need to know about that. Okay, Bell Canada have announced quite recently, it was in December of 2016, that Bell is doing some work, close work with AT&T on this eComp platform. And it's really a platform where developers are going to be able to fully define network function, create new networking service, okay, from the software layer, purely software. So we're defining the complete network, you know, on the software base. So this is the notion of I have a wide computing stack, very dynamically, very nimbly, being able to create new service and allocate my computing capacity to what is needed, okay, in this in a very dynamic format. So open compute, open hardware, open software. So the notion of computing being open to anyone that wants to contribute, the notion of large and smaller player with talent and good idea being able to leap advance in networking. All right? Good. So that was my topic for the day. Okay, thank you very much.
All my fault. Thank you very much, Denis, for speaking about the whole advancement of open compute. I have to admit, it was quite interesting to see that if you conceptualize the idea of a switch at your near your desktops, deploying images to all your desktops directly from the switch, or in the data center directly deploying images right from the switch, because the switch is an OCP switch and you can program the heck out of it, do whatever you want, you can throw images onto it, or as you see fit. And that was actually being demonstrated and being literally used by various companies. It's pretty impressive. And like Denis said, get out there if you want to participate in this. They are so open about your participation. Even I joined on the data center side. They have facilities, power, cooling, design at that level. So it's not just about the piece of equipment as we learn. It's really every aspect of it. And the idea, what I digested was that if you're in Europe and you have a facility and you want to move your equipment, you want to move it over to North America, well, you know, it's a different power distribution. You know what? This is open compute. Everything should just work modularly. And you might have a little bit of alterations, but really it's very, very simple to switch. So with that, I'd like to open the floor for some questions. I'm going to pass these mics to a couple of the folks here that will walk around and ask a question. If anyone has any question, Denis, you're going to have to stand behind the podium, and I'll get an additional mic for the next sessions. Thank you.
Questions?
Hi, Dave Johnson, Confault. I noticed there's no data element, as if it doesn't matter what the format is. It's physical, it's hardware, it's also networking though. But are there any limitations, or is it a completely open, whatever you want to push through the environment, however you want to manage it at the application layer? Data of all flavors, no issues.
Again, I'm not a coding expert, okay? But obviously, like most of the back work is Linux based in this world right now. And again, it's really the concept of being able to push whatever workload, okay, these companies want to push through. Yep. Okay.
In the back where you've got the bus bars, there were it sounded like a connector that had some ability to connect to the rack from a machine. I didn't know if you had any idea, or what does it do? Is it possible for machines to indicate to the rack or to the data center that something is wrong with fans or power supplies, or are there connectivity between those machines that you're deploying with the rest of the machines out there?
Yeah, you know what? Absolutely. There's one of the work group have to do with hardware management, okay, and they're defining like communication plane between the machine to allow like either you know, monitoring of alarm status on the machine, or even being able to map out, you know, what's available out there, what piece of equipment is located where. So absolutely, you've got one of the bus bar on the left have you know, a basic communication layer in it, allowing for hardware management to happen there.
It's bidirectional.
Yeah, yeah. And again, the flow of information obviously much, you know, varies either ways, but absolutely, okay. Yeah.
I've got a question here. You know, the idea of the open compute was to standardize everything, right? Like, but you have your Facebook who kind of started this, and then Google goes ahead and starts changing things. Is there still a sense of competition between them, even though you're trying to get to that standardization?
Yeah. You know what, it was kind of interesting to realize that even though like Google and Facebook have been working on their own stuff, you know, for years, when they came together, the result was, you know what they're doing is quite similar, all right? Yeah, Google moved a couple years back from 12 volt DC at the rack level to 48 volt DC. They're claiming like a 20 to 30% energy gain in power conversion there by doing that. So Facebook now is even considering going to 48 volt at the rack level, all right? But at the end of the day, they were quite close in terms of the philosophy of, you know, front access and containment, and really defined path of supply and return air, of integrating the rack into the data center airflow management system. I guess because Google is as big as they are, they had a lot of leverage, again, for the standard to be, and they're not really standard, by the way. They're called, they're more like, you know, working framework of concept.
Levels of guidance.
Yeah, yeah, okay. Yes?
Is each, I'll call them working groups, is each working group headed by or leaned heavily by some large organization like a Google, like a Facebook?
Yeah, like for each group you've got a chair and a co-chair, okay? They come from everywhere in the industry. In some of the group there are people from Facebook, like the group I'm in, yeah, the guy's name's Steve Mail, he's one of the Facebook engineer, all right? But it varies from project to project. And you know, I really get a sense there that it's really about, and I really mean that, okay, you meet people there, when you go there, you meet people from you know, all companies. It's not, I'm not feeling that the Facebook or the Google have a stronger voice there. It's really about result and where they're going and efficiencies, yeah?
Well, that is my concern. Does it end up being led by whoever has the most clout, shall we say? In the industry?
And I, you know what? I would say not. Okay, I'm looking at the work being done, and I'm seeing like contribution from much smaller player have big influence on where it's going. Okay, absolutely.
Yeah, we do see, like I was just pointing myself, smaller player, really small player. You can contribute all you like. And even the code that gets compiled, I mean, you can choose, there's a plethora of code that you can use, and they build upon that, and there's just more options for you how you want to use it. It's really fancy. I think it's fantastic. Anyway, you know what? We should mosey on. I took a few minutes of your time. Thank you very much.
All right,
Sorry about the remote.
I will be there.